Hello everyone. Now coming to we are going to the moving our project to the review 2. So here are my teammates Bhavana, Bindu, myself Divya and Manasa and Sinchana. Here are the quick overview of contents, implementation, accuracy and performance results, dataset suitability and handling, evaluation matrices and results, result interpretation, visualization and reporting, conclusion and future improvements and key takeaways and the next steps. So now coming to the implementation, we have implemented a random forest algorithm. The random forest algorithm is an assembled machine learning method that combines a multiple decision trees to make some more accurate predictions than a single model. Each decision trees analyzes a different subset of the data and reduces the overfitting and improving a generalization. So assembled learning combines a multiple decision tree for improved accuracy and the robustness. Decision trees are the building blocks to analyze a subset of data to predict the accuracy. Bagging and the random subspace techniques that enhances the diversity and reduces the correlation between the trees. So hyperparameter tuning such as optimizing the n underscore estimators, that is the number of trees, the maximum depth of the each tree is crucial for achieving optimal performance out of the bag error estimations that provides a reliable ways to assess the model generalization error. Now coming to the training data, it has been divided into the classes that is A, B and C, and the bootstrap which is used to train the model, and the bootstrap is divided into the assemble of trees, that is the decision tree 1, decision tree 2 and decision T3 and the decision tree up to the n, which is bootstrap which is used for the training of the decision trees. The decision trees is classified into the classes, that is class 1, 2 and class 1. So the major oat which is come to the class 1. Now coming to the code, which is the import pandas and which is a handling of the necessary libraries, and the MATLAB import pandas MATLAB which is used for handling of the necessary libraries, and from sklearn which is used for the random forest regressor, and model, and for it is used for the modern learning selections, that is training data and testing data, and from sklearn matches which is used for the printing of the mean square error and the r square error. Now coming to the loading of the data set, which is df is equals to pd dot underscore csv. We have collected the data from the Microsoft data, historical data from 2010 to 2024. So now converting a data into the real time date and a subset of the date. Now extracting a date, year and a month. Now features the now coming to the features and the target point, that is how target value, that is open, high, low, close and year and month and date. And now the data is split into the training data and the testing data, that is training data 80% and testing data 20%. Now coming to the training of the random forest model, to that is the, for example, model random forest regressor n underscore estimator is equals to 100 and the random state is equals to 42. So the model is fit into the training data. Now further predictions will be continued by Manasa.
Coming to the predictions, the trained model predicts adjusted close prices using the test set. Model performance is evaluated using mean squared error and R square score. If the mean square is lower, if the mean square is lower, the performance is better. It measures average squared prediction error. Coming to the R squared score, closer to 1 means the model explains more variance in the data. From lines 38 to 50, we have visualization. A line graph is plotted to visually compare actual versus predicted prices for the first 100 test points. The x-axis represents the sample index and the y-axis shows the adjusted close price. This visualization helps demonstrate how closely the model's predictions match the real data. Next, we have accuracy and performance results. To evaluate the effectiveness of our predictive model for Microsoft stock prices, we focused on two key performance metrics: mean squared error (MSE) and R squared score. Mean squared error is a common metric used to measure the average square difference between the actual values and the predicted values by the model. In simple terms, it quantifies how close or far our predictions are from the real stock prices. A lower MSC value indicates that the predictions are more accurate and closer to the true values. In our case, the random forest model produced an mean square error of 0.2136. This is a relatively low error, suggesting that the model is performing well and generating predictions that are very close to the actual observed stock prices. Such a low value is a strong indicator of good predictive performance. Next, R square score. The R square score, also known as the coefficient of determination, is another crucial metric that evaluates how well the model captures the variability in the dataset. It ranges from 0 to 1, where a value closer to 1 implies that the model is able to explain a large portion of the variance in the target variable. Our model achieved an R square of 0.9784, which means that the 97.84% of the variance in the Microsoft stock prices can be explained by the features used in the model. This is a very strong fit and confirms that the model has successfully learned the patterns and relationships in the data. Along with the metrics, we also performed a feature importance analysis to understand which factors contributed the most to the model's predictions. The analysis revealed that the following features were the most influential: volume, adjusted close, and RSI. Volume, the number of shares traded has a strong impact on price movements. Adjusted close, this reflects the true closing price adjusted for splits and dividends, providing a more accurate picture of value. RSI, Relative Strength Index, a technical indicator that helps identify momentum and potential price reversals. Next will be continued by Bindu.
Data stability and handling, data acquisition and pre-processing. Data source. The historical stock data from Microsoft was acquired from the finances covering the periods from 2010 to 24. We are going to predict the 2025 stock prices. This data set included the daily opening, high volume, close and adjusted closing prices. Feature engineering. In addition to a raw stock data, several techniques indicators were calculated to provide additional predictive power. This includes the moving average from 50 days to 200 days, relevant strength index RSI, and moving average convergent and divergent MASD. Data cleaning. The data the dataset was cleaned to handling the missing values and outliers. Missing values were interpreted using the approximate methods such as forward filling or mean interpretations. Outliers were identified and addressed to prevent them from the skewing influences the models. Coming to the evaluation matrix and results, the data is split into training 80% and testing 20% is to evaluate the performance on unseen data. The random forest regressions from screen learning we use to build the predictive models. Hyperparameter optimization is performed using the grid search CVs or randomized search CVs to identify the best parameter settings. Coming to the data splitting, training 80% and testing 20%. Model training is random forest regressor. Hyperparameter tuning, grid search CV or randomized search CV. Evaluation matrix includes a mean squared error and R squared to measure the accuracy of the predictions. Cross validation is used to access the model's robustness and generalize the capability. Next, we'll continue by Bhavna.
Result interpretation. Now, futures importance insights reveal keys derives behind MSFT stock price movement values is identified as the most influential factors and reflecting the market liquidity and trending activities and adjusted close price is also significant, indicating the importance of historical price trends values uh, value most influence factors reflecting market uh, and trending activities and adjusted close significant indicators influenced by the historical price trends and co- corporate influenced by historical price trends and corporate actions. Next, visuals and reporting, predicting versus actual float, visual comparisons of the prediction and actual stock price and over time, and uh, future importance float graphical represent of the impact of each indicator under prediction and reduced analysis error distribution visualizations to check model assumption. Visualizations play a key role in understanding the model's performance and result plot of the prediction versus actual stock price allows for visual assessment of the model accuracy. Next, we'll explain Sinchu.
Algorithm that proves the effective predicting of MSFT stock prices and offering high accuracy and valuable insights, which also enhance the model considering feature engineering to capture more complex relationships and incorporate sentiment analysis from any articles in the market sentiments. First one we have feature engineering, second one we have sentimental analysis, and third one we have deep learning. Feature engineering is nothing but it enhances the accuracy of the algorithm that is trained to the machines, and sentimental analysis is incorporate market sentiments. Deep learning we includes explore LSTM and GRU. The random forest model has proven to be effective for predicting the Microsoft stock price predictions. Future improvements could involve enhancing future engineering, incorporate sentimental analysis from news articles, and which is exploring deep learning models such as LSTM and GRU. These enhancements could further improve the accuracy and robustness of the predictions. Coming to the key takeaways and next steps. In summary, the random algorithm is very powerful predicting the Microsoft stock prices. This model achieves the highest accuracy and identify the key factors which includes the stock movements. First one we have model deployment, ongoing monitoring and strategy refinement. Model deployment it deploys the model for the real time production predictions, means it predicts the data, and ongoing monitoring continuously monitors and recalibrate the model. Strategy refinement refine investment strategies based on model insights. Future steps includes the deploying the model for real-time predictions, continuously monitoring its performance and refining investment strategies based on the model's insights. This action will help maximize the benefits of the stock price prediction project. Thank you all.